Hello everyone, welcome to Zenith Integral Academy, and in this tutorial we are going to be looking at how to find the differentiation of some inverse trigonometric functions. And some of the basic inverse trigonometric functions that we have includes our sine inverse of s, our cos inverse of s, and tan inverse of s. And each of these functions depends on the assigned values of x, and in most cases we might be asked to find their derivative. So let's go into the content matter. So how do we find the differentiation, that is the dy dx, of each of these inverse trigonometrical functions? So let's start with the first one, and that is how to find the derivation of sine inverse of x. So let's look at it together. So whenever we are asked to find the derivation of sine inverse of s, so this is the necessary step that we need to take. Step 1, you said let y to be equal to sine inverse of x. Now if y is equals to sine inverse of x, for us to remove this inverse function, we are going to be having sine y to be equals to x. That means I've already removed this inverse function, meaning this minus 1. Now since we said s is equal to sine y, we are going to differentiate x with respect to what? To y. And if I should differentiate s with respect to y, I'm going to be having dx all over dy to be equal to, if I should differentiate sine y, I'm going to be having cos y. And if I should have cos y, and since I know that whenever we are asked to find derivation, meaning I'm asked to find the dy dx, so how can I turn this dx dy into dy dx? That means I have to take the reciprocal of both sides. So we said take the reciprocal of both sides. If I should take the reciprocal of both sides, I'm going to be having dy all over ds to be equal to 1 all over cos y. So this is what I'm going to be having, 1 all over cos y, 1 all over cos y. And now since we're able to get the dy ds to be equal to 1 all over cos y, so we are not going to stop here. But from the knowledge of trigonometrical identities, we know that cos square y plus sine square y is equal to 1. Now, if cos square y plus sine square y to be equals to y, that means we want to make our cos square y the subject of the equation. So if I should make cos square y the subject of the equation, I'm going to be having cos square y to be equal to 1 minus sine square y. If I should transfer sine square to this side, I'm going to be having this. And I know that my sine y is equal to x, meaning anywhere I see sine square y, I'm going to be having what? S square. So I'm going to be having cos square y to be equal to 1 minus s square. And since I want to interchange this my cos y in terms of x, meaning I'm going to be having my cos y now to be equal to square root of 1 minus s square. So substitute this. Let's call this our equation 1. Let's call this our equation 2. So we said input equation 2 into what? Into 1. Meaning anywhere I see cos y in equation 1, I'm going to replace it with square root of 1 minus s square. So I'm going to be having my dy all over ds to be equal to 1 over square root of 1 minus s square. So this is the derivation of the y dx. Meaning whenever we are asked to find the first derivative of sine inverse of x, we are going to be having it as 1 all over square root of 1 minus s square. Thank you very much.